Okay, so today we're going to be working on multiplication properties of exponents, and you'll be able to evaluate and simplify expressions with exponents by multiplying. So there's a lot on this slide, and I am going to ask you to pause the video right here and write down all of this. It will make more sense as we go along, but you need to remember all of these points about simplifying exponential expressions. So I will read through them, but you need to write them all down. So you cannot leave an expression with a negative exponent and it be simplified. So in order to simplify, get rid of your negative exponents. Make sure that you do not have the same base more than once in a product or a quotient, and I'll show you examples in the next slide. We also cannot have powers that are raised to powers. We'll look at that later. We cannot have products that are raised to powers or quotients raised to powers, and any numerical coefficient in a quotient should not have any common factor other than 1. Simplify, guys. We know how to do this. Okay, so pause, make sure you've written all this down. I should be able to see notes tomorrow. All right, so here are some examples. These on the left are all simplified. I like these, but these on the right all have problems with them. Let's talk about why. So here I've got a negative exponent. I said on the last slide I cannot have a negative exponent and have it be simplified. Here I have two bases that are the same. I've got an x here and an x here, and we're going to talk in a minute about how to combine those. Here I am raising a power to a power. Can't have that. Here I have not simplified. 10 and 4 are both divisible by 2. A and B are both being raised to a power. So remember, you can't have products that are raised to a power. And I also cannot have a quotient that is raised to a power. And we'll look at how we can get rid of those in the next couple of slides. So the product of powers property. So let's take a look at that for a second. So I've got 3 squared times 3 to the 5th. Well, let me figure out what 3 squared is. We all know that that's 3 times 3. And I'm multiplying that, so I'm going to put this in parentheses just to show that I'm multiplying that by 3 to the 5th. So I've got 3 to the 5th is 3 times 3 times 3 times 3 times 3. So I've got 5 3's here and I've got 2 3's here. How do you think I could combine those? Well, in fact, what I have is 3 to the 7th because I've got 7 3's. Notice what I've done. I've had 3 squared and 3 to the 5th. If I add those two exponents, that gives me the 7. And in fact, that is my rule. If A is any non-zero real number, and M and N, those are my exponents here and here, are integers, then A to the M, so 3 squared, times A to the N, 3 to the 5th, equals A to the M plus N. So I've added my 2 and my 5 to get 7. So let's keep looking at those. Here I've got A 2 to the 4th times 3 to the 4th times 2 to the negative 2 times 3 squared. All right, well, first of all, I've got a 2 and a 2. I've got the same bases, so I can combine these. So I've got 2. Remember, I'm going to add my exponents. Here I've got a positive 4, and here I've got a negative 2. So what I'm left over, 4 minus 2 is 2. So I've got 2 raised to the second power. I've got 3 to the 4th and 3 to the 2nd. Same bases, so I can combine these. The exponent 4 and 2. Remember, my rule says add the exponents, so I'm multiplying that by 3 to the 4 plus 2, or 6. Okay? And for right now, I'm just going to leave it like that, and that's fine with me. Here I've got all variables, q to the 3, r squared, and q to the 6th. Well, r squared's all by itself. I don't have any other variables that have an r, but I do have a base here and a base here that are the same, so I can combine those. I've got q to the 3rd and q to the 6th. I'm going to add those for q to the 9th, and I'm still multiplying that by r squared because I didn't need to combine that. Okay, n to the second times n to the negative 6 times n. Remember today I told you if you didn't write that n to the 1, you might forget to add that in. Well, what I meant was we're adding our exponents. So I've got a positive 2 and a negative 6, which takes me to negative 4, and another positive 1, which is negative 3. So I could write n to the negative 3, except what did I say a couple slides back? That I can't leave a negative exponent. So remember, I'm going to switch that. This goes below the line, so I've got 1 over n to the, and this becomes a positive 3. So 1 over n to the 3 is my final answer. Okay, you've got the product of powers property. Now we've got power of a power property. So let's take a look at what that is. So if A is any non-zero real number and M and N are integers, so I've got some number being raised to a power that is then also raised to a power, then I'm going to use that base, and the exponent is the product of the two powers. So let's look at some examples so this makes sense. So I've got 5 squared and that whole quantity raised to the 4th. Well, that in fact means 5 raised to the 2 times 4, m times n. 2 times 4 is 8. So this is 5 to the 8th. 3 raised to the 4th raised to the 5th is going to be 3 to the 20th. 4 raised to the 3 raised to the 0, of course, is going to be 4. 3 times 0 or 0. And we all remember that any number raised to the 0 power is equal to 1. Now I'm raising a variable to a power. So I've got x raised to the 3rd raised to the negative 5th. Remember, I'm going to multiply those. So I've got x raised to the negative 15th, and I'm multiplying that by x to the 4th. Well, going back to the product of powers property, what did I say? I needed to add these. So this becomes x to the negative 11th. Again, I cannot leave a negative exponent, so my final answer, totally simplified, is going to be 1 over x to the 11th. One more example for you. Made this just a little tad more complicated, but it's all good. So I've got a raised to the 3 times 4 or 12th, a to the 12th, and I'm multiplying that by a raised to the negative 2 times negative 3 or 6. So a to the 6th, which gives me a to the 18th. Okay, remember that was the property that we just learned. We added same base, we add the exponents. Okay. Power of a product property. So if A and B are any non-zero real numbers and n is any integer, then a times b raised to the n. Essentially what I'm doing here is I'm distributing that exponent to both of the numbers that I was multiplying. So let's go ahead and look at some examples. I'm raising 4 and p to the 3rd power because these are inside the parentheses. This is a product of 4 times p, and I need to, in effect, distribute that 3. So I've got 4 raised to the 3rd power and p raised to the 3rd power. Okay, 4 raised to the 3rd power, of course, is 48, and just p cubed. Okay, and okay, remember this negative sign is outside of my parentheses. That means my base is 2y, not negative 2y. So I'm going to distribute that exponent. So I've got 2 squared, or 4, and y squared, 4y squared, and that negative applies to the whole thing. Okay? Now the negative sign is inside my parentheses. which means that this is my base. The negative is included in my base. So if I am squaring the negative, that two negatives becomes a positive. So I've got a positive 25 t to the 2 times 2 or 4. A little more complicated, but let's go through this quickly. I've got x squared y cubed all raised to the 4th. I'm going to distribute that 4 to both. So I have x to the 8th, y to the 12th. And I'm multiplying that by, distribute this, I've got x to the negative 8th and y to the negative 16th. So now remember, I can't leave this because I've got bases that are the same, so I need to combine my, my exponents by adding. So this becomes 8 and negative 8. I'm adding to get 0, so x to the 0. And y to the 12th and negative 16th is going to give me y to the negative 4th. X to the 0, of course, is 1. And this y to the negative 4th is going to drop down to 1 over y to the 4th. Okay, one last example. I am just going to solve x to the 12th times y to the negative 6th. Of course, I cannot have a negative exponent, so this becomes x to the 12th over y to the 6th. Okay, I got one real-world example for you, and then you're going to be on your own to try some examples. Okay. Oh, you're just watching me. Okay, very cool. All right, and so for your real-world example, light travels at the rate of 1.86 times 10 to the 5th miles per second. I want you to find the approximate distance that light would travel in 1 hour. And so I'm going to figure out what that is, and then I'm going to write that answer in scientific notation. And actually, I'm going to show you how it's probably going to be easier to multiply in scientific notation. So this is the speed per second, and now I want to know in 1 hour. So if that's for 1 second, I've got 60 seconds in 1 minute, and another 60 minutes in an hour. So I'm going to have to multiply this number by 3,600 in order to find out how fast it's traveling in a whole hour. So I'm going to rewrite this number in scientific notation. You should know how to do that by now. That would be 3.6 times 10 to the, I've moved over 3. So I've got the problem 1.86 times 10 to the 5th times 3.6 times 10 to the 3rd. Okay, so here I've got the same bases. So 10 to the 5th and 10 to the 3rd. So what was my rule? I take my power, my base, and I raise it to this power plus this power, so 10 to the 8th. And then I'm going to multiply these two numbers, 1.86 and 3.6, which is going to get me 6.96. Nope, sorry, 6.696. So my final answer is 6.9696 times 10 to the 8th. Prove it to yourself by going back and writing this out in standard form and multiplying by 3,600 and see if you can find the same answer. Okay, and finally, here is a some practice for you. Go ahead and write these out. I'd like you to bring these to class tomorrow, so make sure you've written these 7 questions on a slip of paper somewhere and show me your work where appropriate. So bring these to class tomorrow and hope you've been able to do your Khan Academy. I will try to work out the kinks by tomorrow.